All right. Anybody get an answer for the first one?
I actually cannot figure out the first one.
What'd you get for the first one, gang? Bailey? No. No. We need to translate this. How does this translate? 3 to the 1/3 equals x. 3 to the 1/3 equals x. What does 3 to the 1/3 mean?
Cube root of 3.
Cube root of 3. Groupies. This is big. You need to know that this means 3 to the 1/3 equals x. You cannot not know that. All right, what'd you say for the next one?
3.
And you could do that the same way if you wanted. You could say 2 to the x equals 8, or you could rewrite the 8 as 2 cubed. Either way, the answer is indeed 3. Okay, what'd you get for the next one?
Square root of 7.
And again, this is the log base e of e to the root 7, so that's going to be root 7. Or you could set the problem equal to x and translate it. What's the base here? E. So e to the x equals e to the root 7, so clearly x equals root 7, whichever way you like to think about it. What about d? No radicals in logarithm land, so we'll think about that as 8 to the 1/5. So the log base 8 of 8 to the 1/5 is 1/5. Bailey?
Why could we have the radical in the last one?
Because that actually is the answer. We don't have to rewrite, and if you want to write that as 7 to the 1/2, that's fine. What about e?
-6.
Exactly. This is e to the -6. 1 over means negative exponent. So the base here is e. Log base e of e to the -6 is indeed -6. Good job. How about f?
0.
0. The log base 9 of 1 is what? That means 9 to what power is 1?
0.
It has to be 0. And g?
6. Log, Gemma.
Lots of different ways to do this. One way is to just forget that for a moment and say this is the log base 2 of 2 squared. And what is the log base 2 of 2 squared? 2. But you're timesing by 3, so the answer is 6. Another way to do it is to recognize that a coefficient in front of a logarithm always represents a power. So this is the log base 2 of 4 cubed, right? Which is the log base 2 of 2 squared cubed, or the log base 2 of 2 to the 6th. Either way, the answer comes out to be 6, right? All right, number 2, growth or decay?
Decay.
Decay, how do we know?
Less than
The
1.
0.14 is less than 1. How much less than 1?
86%.
86%. That's your decay. You're decaying 86%. What is the initial value?
18.
18. LOG is the symbol for? Log base 10. It's the symbol for log base 10. And what is the name we give to base 10 logarithms? They're called common logarithms, as opposed to log base e logarithms, which are natural logarithms. Okay, number 4, did you simplify that? Oh my, the person that washed my board did an absolutely terrible job. Okay. What did you do here?
Move the 10 to the bottom.
Now, remember, with these kinds of problems, there is no absolute way you have to start. You can do lots of different things. So Robert said, I want to move this guy to the bottom. Okay, we can do that. And when we move him to the bottom, since there's already 8 of them down there, we'll have 18 of them down there, right? Right? Okay, now what?
You have to half the. Oh, move the x to the 4th.
Yeah, probably what I would do first, and again, there's no absolute rule, but we could simplify this, couldn't we?
Easier.
So that would be 9x over 16y to the 18 to the 1/2, because 4 of those are going to cancel and 5 of those. Now we need to raise everything to the 1/2 power, and what does 1/2 power mean?
Square root.
Square root. So I'm not going to write 9 to the 1/2. I'm going to write 3, the square root of 9. X to the 1/2 or root x. If you prefer to write root x, that's fine. 16 to the 1/2 is 4, square root of 16. And y to the 18th to the 1/2 is y to the 9. So there should be your final answer. Okay, then we have the log base 4 of x minus the log base 4 of 2 plus x equal to 2. You should know how to do this. What does the subtraction here tell me? This is what we talked about on Friday. It means there's been a division. So these two are going to get put together as x over 2 plus x. Because when logarithms are subtracted, it means the numbers have been divided. Right?
Yeah.
Now, a few minutes ago, I totally freaked out almost because you forgot, some of you, many of you, how to rewrite your logarithmic expressions as exponents. That's the next step. You have got to rewrite this in its exponential form. What will it be in its exponential form? 4 to the second equals x over 2 plus x. Kids, this is how you solve logarithmic equations. You condense all your logarithms into one. This time we did it as a division. And then we rewrite as an exponent. So 4 to the second equals x over 2 plus x. 16 equals x over 2 plus x. Now what? Solve it.
Maybe 2 plus x over.
Multiply, so 32 plus 16x equals x. So 15x equals negative 32. I don't know, did I do that right? So x equals negative 32/15. Now wait a minute. Your little extraneous root radar should be coming up. Because what happens if I try to take the logarithm of a negative number?
No solution.
Can't do it.
Oh.
So is negative 32/15 a possible answer to this problem? No. Now, I want to caution you, sometimes kids think they'll be working through a problem and they'll get a negative answer and they'll immediately throw it out. Don't do that, don't immediately throw it out. For example, if this had been the problem, all right, would negative 32/5 be an okay answer here? Yes, because this is what you're taking the logarithm of, and it would actually still be positive. So it isn't the fact that's a negative number that bothers me. It's when I put it in the equation, I have to take the logarithm of it. That's what bothers me. Okay? So sometimes negative numbers are going to be okay. This one is not. All right?
What if it's like a plus, and like instead of like the subtraction sign, it's a plus
Then you would
sign?
be multiplying instead of dividing.
Okay.
Right?
So
Isn't
that
that our
would be-
property? Okay. Now, the very next page, just like I have my packet full, just flip it over. The very next one has a couple more equations. Let's solve these. Right, so here we go. Speaking of an addition, we have a logarithm plus a logarithm.
Multiply.
So that's going to turn into a multiplication. So it's going to be 2x minus 6. So the log of this times this, right?
Yeah.
Now what?
3 to the 4th.
3 to the 4th equals 2x minus 6. Very good. 3 to the 4th equals 2x minus 6. So 81 equals 2x minus 6. 87 halves. Now, 87 halves, everything's going to be positive, right? No problem, so that can be our answer. What about this one? This is going to be condensed into x minus 2 over 4.
You just drop the logs.
Yeah, this is a little bit different than this one. Do you notice that? Over here, after we did our condensing, we just had a logarithm on this side. There was no logarithm over here. So we had to translate 3 to the 4th. This is different. This says the log of this equals the log of this. Do you see the difference? Doesn't it make sense that if the log of this box is exactly the same as the log of this box, that those boxes must match?
Yeah.
So somebody said drop the logs, and that's what you do. You don't drop them here, why not? Because you only have them on one side, so you got to translate. If you've got them on both sides, then you go ahead and solve. Now, look, did I drop the logarithms in step 1? No. If you're going to drop the logarithms, it has to be log equals log. Not log minus log or log plus log. It has to be 1 logarithm equals 1 logarithm. So step 1 in both cases is to combine those. -2/11.
And that doesn't work.
What's gonna happen if I put a negative number right there? It's gonna be trouble, right? So again, we have no solution. Emma?
Will you ever give us like one log to the fourth and the other like log to like
No,
the
the
sixth?
bases will
They'll all be
match.
the same. Okay.
Okay, underneath that, let's run through these. What's the answer to the first one?
8.
8. Second one,
5 root 3.
3 or 5.
Root of 5.
the cube root of 5 or 5 to the 1/3, whichever way you want to write that. What about the next one?
3.
3, because 3 cubed is 27, right? And can't do this one in my head. What are you gonna do first here? Be careful. He's a problem. What are you gonna do with him?
1/3.
2
Yeah, he becomes an exponent. So this is really the log of 8. Remember, coefficients in front of logarithms are exponents. So this is really the log of 2 cubed. Now what?
multiply.
Put them together as a multiplication. Now, can you drop the log?
No.
No, because you only have 1, so you're gonna have to rewrite. And how does this get rewritten? 10 to the second equals 8x. Where'd that 10 come from? It's the base of the common logarithm. So 100 equals 8x, and x equals 108, which is 25 halves.
Yep.
Any problem with 25 halves? Nope. You okay with that? All right, we're gonna be having a quiz. That's it.
Right now.
Kind of stuff. Be ready. Let's look now on page, back in our textbook. Page. I don't want you to be confused.
Is this more log practice?
Yep, there's more log stuff. I don't want you to be confused when you look at problem slide number 30 and number 34. Number 30 says, write the expression using only natural logarithms. This is a base 7 logarithm. They want you to rewrite this
Base E.
base E. We talked about this on Friday. We want to change this base. We went through it step by step. Oh, there's an X already in it, so it's going to be a little wacky, but I'll just say A. So 7 to the 8th equals X. Now I can take the natural logarithm of both sides. What happens to this guy? Out in front. So our answer is ln x divided by ln 7. We observed that on Friday, the change of base formula.
Yeah.
Didn't we say it was just going to be the log of this over the log of this? I'm using natural logarithms because that's what the directions said. For this one, it says use common logarithms.
it's already.
Okay, so what would that be?
Just the log of x
over log 4. That's all it means. This is a base 4 logarithm. They want you to do it in terms of base 10. So it'd be the log of that over the log of that. This is the natural logarithm of this over the natural logarithm of this. Okay, it's easy. Don't make it hard. Robert?
So would the final answer be the ln x over ln
Yep.
7? Okay.
Yep, can't do anything else with it. Look at problem number 52. I think I signed that one. Yeah, but let's look at 52. A little word problem. And they give you an equation. What did I say, 52? And they tell you what all these letters stand for. Okay. Then it says compute the magnitude R for each set of values. So A is 250. T is 2, and V is 4.25. Can you do that?
Yeah.
Kids, that is so simple. You just take out your calculator and you type this in. And whatever comes out is the answer. That's not hard, right? Let's look at number 53. Another equation. It tells you what all the letters mean. X is the depth. Tells you that in the problem. So when it says what's the intensity at a depth of 40, what are we going to do?
40 in for x.
Put 40 in for x. So then we're going to have this equation. Go ahead and type that in. Get that value. I got negative .094. Did I get in enough zeros and stuff? Now what? You know, we've done a couple of these already today. You know what to do. Kids, it's a logarithmic equation. And with logarithmic equations, you have two choices. You either drop the logs, is that an option? No, because you don't have them on both sides. Or you rewrite in exponent form. So what's this going to be in exponent form? 10 to the negative .094 equals I over 12. So I will equal 12 times 10 to the negative .094. So let's type that in on our calculator. Somebody shout it out. What'd you come up with?
9.66.
9.66. Is that okay with everybody? Okay, would you look with me on page 331? everybody on page 331?
Mhm.
I'm gonna look at number 2. And at number, I guess 12. Would you agree these are both exponential equations? Yep, where's the variable? In the exponent. This one, I'm going to ask you to do without a calculator. This one, you're going to have to use a calculator. What's the difference? Why can this one be done without a calculator, but that one can't?
Whole numbers.
What?
There's like whole, like no decimals.
It's not really the decimals. That could be a decimal. That could be 0.25. What's kind of special about the numbers in this
They're all
problem?
divisible.
They're all powers of each other.
Oh, they're all powers of 2. So we can think of this as 2 to the 5th. What about 1/4?
Do the same.
2 to the negative 2nd. And 2 to the 1st. Would you agree with that?
Yeah.
So let's see, that's 2 to the 5th times 2 to the negative 2/3 x equals 2 to the 1st. What happens when I multiply these two things together? What do I do with these exponents? This is a multiplication problem. What do I do with those exponents?
Adam.
Add them. So this would be 5 minus 2/3 x.
So you can just drop the 2's?
Now we can drop the 2's. It's just like the logarithm problem we did. When you get one base on each side and they match, doesn't it make sense that these two things have to match? If 2 to that power equals 2 to that power. So 5 minus 2/3 x equals 1. So negative 2/3 x equals negative 4.
X equals 6.
And x equals, what is it, 6?
Yep.
No calculator necessary. Now, that's one strategy, and you know there's a zillion strategies. Go back to the original problem. I probably, if I were doing this on my own, I would have divided by 32 first. So I would have had 1/4 to the x over 3 equals 1/16. If I divide both sides by 32. And then 1/16 is 1/4 squared. Right? So this equals this, so x over 3 equals 2, which means x equals 6. Just another strategy, just another way to think about doing the problem. Now what about this one? There's no common base between these two numbers. You're not going to be able to get these to match. So what do we have to do? Well, how do we use our calculator? Yes, we use our calculator. How do we do
Take the
that?
log.
Take the logarithm of both sides. So we're going to take the logarithm of both sides. And why did we do that? What is the beautiful, beautiful thing?
We can.
You can drop the log.
That guy comes out in front. And then I will divide. And I physically type that into my calculator. I don't cancel anything out, nothing cancels. I physically type exactly what is written on the board. And I got negative 23.26.
not to cross out the 2 logs before you did the division?
At this point,
Yeah.
okay, you can only drop the logarithms if you have the log of this equal to the log of this. What's different about the way that looks?
There's X.
That's why. And if you said, well, but Mrs. Ford, that X is really an exponent,
You drop the logs.
now you can drop the logs, but where would you be?
Back.
Back to the original problem, right? All right, let's try a couple more. Again, no calculator. We'll start with number 4. 4 is a no calculator. Oh, and I know what you're thinking. You're thinking, oh, there's a 3 and a 4. You can't get a common base between 3 and 4, but what might I do to get started?
Cancel the minus 2.
What if I divided first? What if I got rid of that 3? What would that leave me with? 4 to the x over 2 equals what if I divided by 3? 32. What about that? 4 and 32 are both powers of 2. So this is 2 to the 2nd, and this is 2 to the 5th. You couldn't get a common base at the beginning, but as soon as you divided by 3, then everything fell into place. So what's this now? 2 to the what? X equals 2 to the 5th. What's the answer? X equals 5. Those are easy. We like those. What about 16? I'm going to need a calculator to do number 16. How do you think we'll start this?
Could you move the 7 over?
Yep, definitely. Move the 7 over. So that'll be what, -5?
Divide by 1/3.
Well, divide by -3.
3.
So e to the negative x equals 5/3.
Take the natural log.
We're going to take the logarithm of both sides, and it doesn't matter, but since there's an e in the problem, it kind of makes sense to go ahead and take the natural log of both sides. What's this equal? What's the log base e of e to the negative x?
Negative x.
Just negative x. So x ends up equaling ln 5/3 divided by -1, or negative ln 5/3. About negative 0.5108. Grace?
No, I figured it
All right, let's do just a couple more, and then I'll stop. Let's do one more no calculator and one more with calculator. How about number 6? This is a no calculator. Trouble in River City. We got a 3 and a 5. Those do not have a common base, but we can probably get ourselves out of this by doing what first? Divided by 3. So 5 to the negative x over 4 equals 5. Whoa, this is easy. What's the exponent here?
1.
So 5 to this power equals 5 to this power. What's your natural conclusion? The powers are equal. So x equals -4. good with that? We'll do one more with calculator and then I'll just stop. How about number 14? Step 1,
Divide by 80.
divide by 80.
3. Get the natural log of each step.
And what happens when you take the natural log base e of e to that power? It's just the power.
And just it could be x equals natural log of 3 divided by 0.045.
Yep. Which is about 24.41. You okay with that? All right, I'm gonna change up our assignment. I'm sorry if somebody already did it, but I did it. It's kind of where I assigned, so I'm gonna change it. What I want you to do tonight is section 3.5. This is the section, the page that we're on right now, 1 to 17 odd. So I want you to do 3.5, 1 to 17 odd. Everybody okay with that?
Those no calculator.
Some, half of them are none and half of them are with. 1 to 17 odd. 3.5, 1 to 17 odd. That's what I want you to do tomorrow. Also, tomorrow we're going to have a quiz. This isn't on the quiz. Well, actually, that's not true. We have had problems, log base c of e to the 0.045x. You're supposed to know that's 0.045x. That's one of the problems. So quiz tomorrow will look like that practice quiz we did. Right? Is this the cup that's causing so much damage?